When an electric current flows through a wire, the wire gets heated. It is the heating effect of current. This effect has many applications. This heating effect of electric current is used in the electric appliances, and also this heating effect is used to prevent the fire and short circuit damages to the electric appliances in the means of electric fuse. Wires made from some special materials melt quickly and break when large electric currents are passed through them. These wires are used for making electric fuses. There is a maximum limit on the current which can safely flow through a circuit. If by accident the current exceeds this safe limit, the fuse wire blow off and break the circuit. Fuses of different kinds are used for different purposes. Always use proper fuses and never use just any wire or strip of metal in the place of fuse. These days, miniature circuit breakers MCB are used in place of fuses. These are switches which automatically turn off when current in a circuit exceeds the safe limit.
Of the fact that electric current heats up objects through which it flows. Electric water heaters, light bulbs and electric iron are few of the electrical appliances that make use of this fact. However, it has its drawbacks too. For instance, if these appliances are overheated, then they may get damaged or even catch fire. In fact, not only these appliances, every appliance in our house is affected by the unwanted high electric currents. There is a limit to the amount of electric current that any device can withstand. If the current exceeds that limit, the components of the device heat up and this may even lead to fire. So, is there any way to prevent that from happening? There is a device which is used to prevent this and it's called electric fuse. Well, it comes in many shapes and sizes. This is what it generally looks like. It has a fuse wire and is connected to the two terminals which are made up of some metal. This wire is made up of zinc, copper, silver or aluminium. The rest of the switch is basically made up of a non-combustible material. And it makes perfect sense too. We should make sure that the device which is used to prevent fires in other devices must not catch fire. Now, how does it prevent household electrical appliances from catching fire? Well, this fuse is introduced in every circuit in our household. This is how the basic circuit would look like. We have seen this simplified circuit in our previous videos. Okay, so when the current flows through the circuit, it heats up the fuse wire. And when there is a heavy current in the circuit, the wire simply melts, resulting in the broken circuit. Yes, the circuit breaks and the current does not reach the appliance. So this is how an electric fuse functions. Simple, isn't it? Now there is one obvious disadvantage of electric fuse that you must have noticed. Once the fuse wire melts, it cannot reform itself. We have to replace the fuse with a new one manually. To overcome this problem, automatic fuses are used nowadays. They are also called miniature circuit breakers, often abbreviated as MCB. They work like automatic switches. Whenever there's an excess amount of current flow in the circuit, they automatically switch off. This breaks the circuit and the appliances are saved from excessive current. They also automatically get switched on when the flow is back to normal.
The next effect of electric current is magnetic effect. Through an activity, let me discuss about that.
We have taken a cardboard tray. It is wrapped with an electric wire. A small compass needle is placed inside it. The free ends of this wire are connected to an electric cell through a switch as shown. Note the direction in which the compass needle is pointing. Now, switch on the circuit with a plug key and observe the compass needle. We can see that the compass needle deflects. Now, unplug the key and observe. We can see that the compass needle comes back to its initial position. Repeat the experiment few times. We know that compass is a tiny magnet which is affected by any magnetic field around it. In this activity, we have seen that the compass needle gets deflected when the current flows nearby. This means that there is some magnetic field created around the compass when current is passing through. So, when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. Thus, we find that electricity and magnetism are related.
We know that the needle of a compass is a tiny magnet which points in north-south direction. When a magnet close to it, the needles get deflected. It do the same when it is nearby the current carrying wire. This is what a scientist called Hans Christian Ørsted also wondered. He was the first person who noticed the deflection of compass needle every time the current was passed through the wire. Take a long piece of insulated wire and wound tightly around an iron nail. The free ends of this wire are connected to the terminals of the cells through a switch, and place some pins near the nail and switch on the circuit. Now the current flows through the circuit and the pins are cling at the tip of the nail. When the switch is off, the pins are released. The coil behaves like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. The electromagnet can be made very strong and can lift very heavy loads. Do you know how does an electric bell function? That is the calling bell or the bank bell of the school. Let me discuss. In the above arrangement, the switch is connected to a cell and it consists of a coil of wire wounded on an iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil. On the big gong, the hammer at the end of the strip strikes, the bell produces a sound. And this is the contact screw near the iron strip. When the current flows through the circuit, the coil becomes an electromagnet. It pulls the iron strip and so the hammer strikes the gong to produce sound. Now the iron strip lost the contact with the screw, so no current flows through the circuit. The strips come back its original position, so again touch the contact screw which make the current flows through the hammer strike the gong. This is how the bell rings.